Okay, so for notes 1.3 day 1, we're going to talk about functions. So a function would be if we have from inputs to outputs exactly one input for each output. You guys should remember, if we have like a picture, we can use the vertical line test to see if it's a function, where you use a vertical line. Any point on this graph, if it hits more than once, it's not a function. And there's other ways of telling if it is or is not a function. We can look at the actual ordered pairs. So this example A right here, if we have x values that repeat to different y values, then it would not be a function. And this next one here, we've got 5 points. You could use the vertical line test for those points. You could actually find the ordered pairs and make them into a table. But with these 5 points, none of them repeat, so this is a function. None of the x's repeat. You could say pass the vertical line test. You're just going to explain how you figured it out. Okay? And then there's a way to determine if these functions, if they are functions algebraically. There's a couple different ways when you solve an equation that you're going to get y equals, and you're going to get 2 different answers. So if you're solving an equation, you get like 2 different answers. Those are the kind that are going to be not a function. So this very first question, I'm going to solve for y. I'm going to add 9. I'm going to get x plus 12. Then I'm going to divide both sides by x. Get y equals x plus 12 over x. And I just have one answer for y, so this would be a function. If you are stuck algebraically, you definitely need to be able to do it algebraically. But if you're stuck, and you know these are just assignments right now, you could go on your graphing calculator, or you could go on Desmos and actually graph it. Look at the graph. Would it pass the vertical line test? That might give you an idea of like, oh good, I was right, or oh no, I was wrong, what did I do wrong? And then kind of you can kind of work yourself backwards through like, what did you miss? Question B, same thing, we're going to solve for y. So I need to first take away x squared from both sides, and I get y squared equals 30 minus x squared. And then to get y by itself, we have to square root. What's the rule? If you guys square root, you got to do something else. Say it louder. Plus minus, thank you. So if you're going to square root, you got to also put in that plus minus. You cannot simplify 30 minus x squared and the square root of that. You cannot simplify that. That's exactly what you'd write. But here, because I am getting a positive answer or a negative answer, that's giving me 2 different ones. So this would not be a function because of that plus minus. Now, just looking at the equation itself, this is a circle. X squared plus y squared is a circle, and that I know is not a function. Can anybody think of a graph real fast that you know is not a function, like a graph that you actually know, not just some crazy squiggle thing, but like, Madeline, what are you trying to say? Besides the circle. Okay, Somebody's talking, but I can't tell. Oh, is that Christopher? X equals y squared would look like this, yeah. So that would not be a function. Along those lines, if you took, yeah, do you have one, Sam?
No.
Oh.
So it's not a function when there's two x values the same amount.
In the table, yes. Yes. And then here's another function that, not a function. But if we took x equals the absolute value of y, if we did the absolute value of y, that would be an absolute value that turns the other way. So it would look like a v that way. So that wouldn't be a function either. Bless you. So those are kind of like the exceptions anyway. All right, function notation. If we input x, we get out f of x. If we input x, we get out f of x. An equation could look something like this. F of x equals 3x minus 10. That is function notation, where we have the f of x in front. Evaluating at a given point. There are 3 equations sitting here, but I did not do a good job of splitting them up. So I'm going to highlight my f equation, my g equation, and my h equation. So I've got 3 equations sitting there. They're all functions. You know, that green and yellow look very similar in color. They're all functions, but there's a reason why they have different letters. So question A says find f of negative 2. What that means is put in negative 2, replace all the x's with negative 2. Replace all x's with negative 2. That's what f of negative 2 means. But the f part tells me which equation to use. So negative 2 squared plus 4 times negative 2 minus 2. Okay. We've got, simplifying that, this will be a negative 4 minus 8 minus 2. So we get negative 14. Negative 14. Okay, when you put your answers, I will put the f of negative 2 part, so I just want you to put in that number so we don't, get things marked wrong. I'll put the f of negative 2 equals, and then you can just plug in the negative 14 part. Second question is g of 10. So now I have a g that tells me which equation I use. Go to the middle one, g of 10. We're going to do g of 10 equals 10 minus 6 over square root 10 minus 2. I'm going to simplify that, and I get 4 over square root 8. If you type that in Canvas, it's going to mark it wrong. You know why? There's a square root in the denominator. That's not the only reason, but that's definitely one of the reasons. Just looking at the square root, somebody want to say that? The square root of 8 also simplifies. So we've got quite a few things we need to do. I like to simplify before I get rid of the 8 in the denominator. It's easier to have a simpler number. So I'm going to simplify it first. So we're going to take that square root 8 and make it 2 radical 2. Do you see something else that could simplify and make my life easier? The 4 and 2, these outside 4s and 2s, we could reduce those, and I get 2 over radical 2. So now I'm going to attack that. We've got a radical in the denominator. You have to do what's called rationalize. We have to multiply by a value of 1. We're not solving an equation. We're just simplifying, so you cannot change the value of it. You can only multiply by the number 1. That's the number 1. We go straight across. I get 2 radical 2 over, and what's square root of 2 times square root of 2? 2. Is that okay for Canvas? Are we good? Nope. Because these 2's are going to cancel out, and we will get square root of 2 as our final answer. And for Canvas, yay, we get to write SQRT2. You do not need the parentheses if it's just one number, like square root 2. You don't need the parentheses. You need parentheses if it's multiple things after the square root. All right, the last question is h of 3. Now, I asked my first bell, and they told me they did not know much about this. So this is called a piecewise function. And with a piecewise function, oops, go away. There we go. With a piecewise function, you've got different pieces that are held together as one function, and the pieces are separated by the domain. They're separated by the x values. So I need to find h of 3. You see the first equation is negative x plus 3, but only when x is less than negative 2. The second piece is x squared minus 10, but only when x is greater than or equal to negative 2. Should I use the top equation or the bottom equation for h of 3? The bottom, because 3 is greater than or equal to negative 2. So we will use that one. We'll do h of 3 equals, we'll do 3 squared minus 10, 9 minus 10, negative 1. Okay, finding the domain. I was just talking about the domain a little bit. The domain would be what x's can be used in that equation. There are certain places where you are not allowed to have a particular x value. If we have a fraction, and in that fraction, if our denominator is 0, can we have a number over 0? No, you cannot have a number over 0. So if we have an x in the denominator, we can't have an x that makes that denominator 0. Other things about the domain is any value that would cause an even root to have a negative number underneath that radical. So if I had the 4th root of negative 25, that could not be in the domain because that would be an imaginary number. Okay, so any number that would cause underneath the even root to be negative. So those would be exceptions to your domain. So for this particular example, f of x equals 1 over x squared minus 4. That's a fraction. So I know that 1 over x squared minus 4 cannot be 1 over 0. It cannot be a number over 0. That is telling me that 0 cannot equal x squared minus 4. I cannot have x squared minus 4 equal to 0. So what x's would make x squared minus 4 equal 0? Right. And you guys just yelled out answers. Did you actually solve it, or you just have known it because you have done that so many times? Did we just know that one? Did we solve it? Okay, well, I'm going to solve it. Just nobody's really answering me, so I'm going to solve it. I'm going to move the 4 over, and then I'm going to square root both sides. And when I square root both sides, I get positive and negative 2. So that's one way of solving it. Right, so this would not have negative 2 or positive 2 in the domain. Unfortunately, on Canvas, I can't write plus minus 2 on Canvas, so we just have to separate them, put them in order from negative 2 to positive 2 if we need to write stuff like this in Canvas, sorry. So the domain would be, using interval notation, it would be all real numbers except for these two numbers. So we would go from negative infinity to negative 2. Could it include negative 2? No. So we'll close that with a parenthesis union, and then we open a parenthesis. We're going to start at negative 2 again, go to positive 2. I didn't leave enough space. Oh wait, I did. And then union, and then we'll go from 2 to infinity. So that's what the domain would look like for that one. So everything except for positive 2 and negative 2 would work. And then, like I was saying earlier on the other worksheet, if you guys weren't sure, but you knew that -2 and +2 were kind of those places that separated pieces of the graph, you could always test points in here. You could test points, like we could test 0, we could test -10 and +10 if you want, just to make sure that it really is all those pieces. All right, the other example, the domain of g of x equals square root 5 minus x does not have what in the domain? Okay, so somebody's already saying the answer, but I can't really tell who it is. Does somebody want to? Sam? Christopher? Louder. Oh, everything greater than 5. So let's see how you could have done that. I know that square root, nope, it doesn't even matter about the square root. I know that underneath the square root, 5 minus x has to be greater than or equal to 0. It can't be negative. So I'm just going to say that stuff underneath has to be greater than or equal to 0. So I'm going to move, let's see, I'll move the x over so I don't have to worry about moving signs around. And I get that x is less than or equal to 5. So now, Christopher, everything that is greater than 5, is that what you said, is not in the domain, right? Right. So does not have numbers greater than 5. Because if we have a number greater than 5, oops, I forgot the 5, then that would make it negative underneath. Here, this is telling me what the domain is. I could graph it if I need to, but we're going to write it into interval notation where we're going to start with -infinity and go to 5, and it does include 5, so we'll put the bracket. Again, if you graph it and you're not sure if it's below it or above it, you always test points if you're unsure. I had to test some points in my homework. Is that my last one? Yep, that's the last one. So I definitely had to test some points. If you guys have questions, this will be due Wednesday at like 11:59 p.m. Don't send me questions at 11:59 p.m. But I am giving you that opportunity for a couple XH bells plus all that time to email me, plus even like during class if you still have questions before it's due. Okay, and then back to the module for today, somewhere on here. I have a million things open. I'm sorry. This is what my brain looks like too. On the module, you will see that the last book page 35, I did not have an answer document for that because there wasn't any graphing in that one. So that one's just all working stuff out. So you can just use a blank page in Kami or your own paper and then upload it that way. Okay? All right. You guys have the rest of the time to work on it. You should work for 6 minutes. Athletes leave in 6 minutes, or bands, if you have practice today. And then everybody else has 11 minutes.